Sorry, students, there was interruption due to disconnect of network. Now our next topic is mm, this topic was for MCQs as well as for MCQs plus short. So remember that the facts about uh, another MCQ type is the very low temperature is about 10 Kelvin, which can be measured with the help of these thermistors. Our next topic is electrical power and power dissipation in resistor. What does this mean? This means we have to consider two types of things: electrical power mm, and power dissipation in thermistor. Now we discuss electrical power and power dissipation in thermistor. For that, as in your book, there is a simple circuit shown where there is a battery. There is a battery connected with the resistor. The battery has the voltage, potential difference E. The name of the battery is E. Sometimes we also talk about EMF of the battery. So sometimes this EMF of the battery is denoted by E. And we say that when a battery of EMF E is connected across the resistance whose total resistance is R, a potential difference V is created across the ends of the resistor R. As a result, current I flows through the resistor. There are two terminals across which the resistance is connected. Why this example of resistance is used? Actually, we want to show that what is happening when a current flows through the resistor due to the connection of a battery across the across some resistor. Let me explain what is happening. Suppose a battery moves. Actually, what is meant by the current? When current flows through the battery, through the wire, through the resistance, this means that charge Q passes through the resistor. The battery uplift the charge Q. Let's suppose small charge delta Q by battery move this small charge delta Q from high potential end to low potential end. When these charges flow through the resistance, they dissipate energy. What does this mean? This means the energy of the charges delta Q uh, is utilized during the flow of this charge through the resistor. When this charge delta Q moves reaches that point B, at point B, the energy which is given by the battery to the delta charge Q will be utilized due to the resistance of this resistor. When the charge reaches at point P, its energy is utilized. What does this mean? This means the energy is dissipated in the form of heat in this resistor. What battery does? Then again battery take this delta Q charge from its negative terminal end to the positive terminal end, mean from low potential to high potential. And the same amount of energy which is utilized by this charge delta Q in passing through the resistor is again given to the charge in moving the charge delta Q from low potential end to high potential end. What does this mean? This means that when charges flow from high potential end to low potential end, they lose energy. And when charges move from low potential end to high potential end, they gain energy. So what battery does? Battery actually provides continuously energy to the charges, and these charges when passes in the form of current through the resistor, this energy is dissipated in the uh, resistor. Now the question is, how much energy is provided by the battery to the charge? We know that the work done by the battery in moving the charge from its low potential end, that is its negative terminal, to its high potential end, that is its positive terminal, will be equal to the charge delta Q multiplied by the potential difference through which the charges move. This is the energy supplied by the battery. This is the energy supplied by the battery. This is equal to the energy supplied by battery. This is the energy supplied by the battery. Usually, we know that the power is defined as rate of doing work and we are rate of energy supply. So, for the present case, the energy supplied per second will be the power of the battery. So, we can say that the electrical power of the electrical power of the battery is equal to the energy supplied per unit time. Energy supplied per unit time. How this can be calculated? If this charge moves through the resistor in time delta t, then the energy supplied to the charger by battery is equal to the work done by the battery divided by the time taken. Suppose this time interval is written as delta t. So from here we can write that V multiplied by delta Q over delta T. But what is delta T? Delta Q over delta T is the current. During the definition of current, we observed that the current I is defined as the total charge passing through a wire or passing through a conductor in time in time in 1 second. For this way, this will be obtained the total charge divided by total time taken. So this will be charge per second. So charge per second flowing through any conductor is called current. So we have utilized the definition of current here in writing delta Q over delta T as I. So electrical power is equal to V multiplied by I. Since this energy supplied or electrical power supplied by the battery is utilized or dissipated in the resistor, so heat dissipated in the resistor can also be defined as, so heat dissipated, let me see what symbol is, no symbol is power dissipated, Q symbol is used for from your book. So we can see that the power dissipated, the word dissipated is usually used whenever the energy, electrical energy appears in the form of heat or any other form of energy when converted into heat energy, then this power is called power dissipated, yeah, energy dissipated, energy dissipated. So energy dissipated is equal to V multiplied by I. Now this formula, this power dissipated is in watt if the potential is in volt and current is in ampere. So you should keep in mind that the power dissipated or energy dissipated will be in watt if voltage is measured, if the potential difference is measured in volts and current is measured in amperes. Also, you can modify this formula by using this relation V is equal to IR, then power dissipated can also be written as I square R. Also, power dissipated can also be written as, if we use, then P can also be, then power can also be written as V multiplied by V over R, that is V square over R. There are different forms of expression for power dissipated in a resistor. For example, power dissipated in the resistor if potential difference and current flowing through a circuit is resistor is given, then this formula will be used. If we know about the resistance of the resistor and current flowing through it, this formula would be used. And if we know the potential difference and resistance of the resistor across which the battery is applied or current is flowing, then we will use this relation. These relations are very important for MCQs plus short question. Actually, this is the whole topic which is very important for the case of uh, short questions, for the short question and as well as for the MCQs. So there are two things. Let me summarize it again. Uh, Power dissipated, electrical power and power dissipated in heat in resistors. Electrical power of a source or a battery is defined as work done divided by time taken. What is work done? Work done is written from the formula in which we defined in chapter 12, where we say that change in potential energy is equal to work done, and this work done is equal to potential difference multiplied by charge of the particle upon which the work done in moving across 2 points whose potential difference is delta V is to be calculated. So in that case, using this sort of concept, we actually calculated the work done. Now, how we develop the story of work done? Actually, we uh, make the observation here that whenever current flows through the resistor, what does this mean? This means that charges flows through the circuit, and as charges flows through the circuit, when this charges comes to the point A, then after passing through the resistor, when these charges arrive at point B, then the energy of those charges will be dissipated during the course of motion through the resistance, because we know that resistance is the opposition offered by the material to the uh, charges passing through it. Whenever if these charges arrive at point B, which is directly connected to the negative terminal of the battery, this means that they have lost the energy. This is also uh, evident from the fact we have already discussed that we know that whenever a charged particle, for example electron, moves from high potential end to low potential end, or positive charge move from low potential and high potential end to low potential end, they actually lose potential energy. This loss in potential energy is equal to gain in kinetic energy in case if charge move freely, there is no material charge move in a vacuum. But when charge move through some material, it faces the resistance. Due to this resistance or opposition, if charge has to move through the resistor, it have to work against this resistance. This opposition is this opposing force. As a result, it will actually lose the energy in doing work against this. So instead of gaining kinetic energy, these charges will move with constant velocity, and the energy uh, loss, potential energy loss by those charges appear in the form of heat energy, or dissipated in the form of heat energy. So this was the basic idea, due to which we know that whenever charged particles move from high potential end to low potential end through a resistor, they lose energy. If this battery is to maintain continuous a constant charge across the resistor, then the energy lost by the charges in moving uh, from point A to point B will again be gained or supplied by the battery if battery will move this charge from its low potential terminal to high potential terminal. So this thus the battery provide the energy to the charges, which maintain the constant current across the resistance, and this energy will be dissipated across the resistor. So we say that the battery supplies energy, and this energy is dissipated in the resistor. This is all about the energy flow and energy dissipated in case of resistor. So according using this fact, we define, first of all we define the power sorry, work done on the charges. And so because This work is done by the battery. So the electrical power of the battery is defined by the work done divided by the time taken by the battery to flow the delta Q charge from its low potential terminal to high potential terminal. So using the definition of current, we arrive at a conclusion that the electrical power of a source or battery is equal to the potential difference uh, maintained by the battery to flow the current I through a circuit is called electrical power. Since the energy, whole energy supplied by the battery is utilized by the charges in moving from high potential end to low potential end through the resistor. So we will see that the power dissipated in the resistor is also equal to V multiplied by I. So this was the idea that how we can define the electrical power dissipated in the resistors. Uh, Students, I think you will be able to understand what is going on. This article is not important for a long question, but may be asked as a long question. But this has very important ideas. Next, we will define electromagnetic force and potential difference and see what is the difference between electromotive force and the potential difference. As I mentioned that sometime we write the battery as EMF, source or electromotive force, source of electromotive force, and V is the potential difference maintained by the battery across the terminals of the 2 points across the 2 points across which the battery is connected. So next, in the next topic, we will explore what is the difference between electromotive force and the potential difference. Thank you very much for your listening.